Hello everybody and welcome to my class. Today we are going to be doing systems of algebraic equations. Okay, so this will be the 7th grade curriculum. So systems of algebraic equations, I'm going to explain what systems are later, and these concepts are really important, so be sure you take notes during the class. And there will also be practice problems provided, so you can practice the material. So this will be our schedule. First, we're going to visualize the solution to systems of equations with graphing. Okay, and then we're going to be solving systems with substitution and elimination later. Okay, you can also solve with graphing, but it's not that efficient. So what are systems of equations? Now, systems or equations are just groups of algebraic equations with 2, 3, or 4 variables, something like that. So let me give an example, okay? It's easier to explain with examples. So remember, a system is a group of algebraic equations, and they have a number of variables, okay? Not one, maybe 2, 3, or 4, okay? Something like that. So a system of algebraic equations would probably look like 3x minus y equals 5y plus x equals 6, something like that, right? So you have two distinct variables, x and y. So you cannot have a z, okay? If you have 3 variables, you need 3 equations. If you have 2 variables, you need 2 equations. Now why? Because if you have 3 variables and only 2 equations, it'll be hard to solve, okay? So what we're doing here is, remember, in our previous classes, we learned about literal equations, okay? And we can isolate the variable we're solving for and put all the other variables and numbers to the other side. But in systems, we're actually solving for the variables, okay? We're actually solving. So another example with 3 variables, maybe x, y, and z. So 2x plus y plus z, something like that, equals 3, something like that, okay? And then 3z plus 2y minus x equals 15, okay? So these are just random ones, okay? So does everybody understand what a system of equations is? So does everybody understand? Yes or no? Okay, yes, very good, very good. So next. So the solution to systems with 2 variables. So today we're only going to be doing systems with 2 variables. This is because I'm introducing you to systems. So 2 variables are easier than 3 variables. 4 variables are even harder, okay? So we're only doing 2 variables today. So the solution to a system of algebraic equations that contains 2 variables would be the intersection of the 2 lines on a graph. So remember, we have two equations. Let's say we have y equals 2/3 x plus 4, 3x minus 3y equals 9. Okay, this is our system. Okay, so these 2 lines can make a graph. For those who have been to my previous classes, this line is in slope-intercept form, right? In slope-intercept form. And this one is in standard form, right? And we can both graph these. And one of the lines will probably be like this. and one of the lines will be like this. In the intersection point, this is just an example. I'm not actually drawing the lines. They probably don't look like that. So the intersection point is somewhere around here. So just visualize the intersection is the solution. Okay. So remember this is very important. The intersection of the two lines on the graph is the solution to the system. Okay. And later we'll practice how to use graphing to solve. Okay. So there are three outcomes to a system of equation. Okay. So one, there's a single solution. Okay. There's only one intersection point, right? You can have two. If they're lines, then you can only have one intersection. Okay. So the intersection, say, is like 3, 4. Okay, that's our single solution. Only one intersection. And usually, when you write out a single solution problem, you have to write it in an ordered pair, right? It's an intersection on a line. Okay, so it has to be written in an ordered pair. Okay, maybe you can do like this is the x, this is the y. Maybe you can do x equals 3 and y equals 4, but this ordered pair form is better. Okay, so I encourage you to use ordered form. So no solution is another outcome. Okay, no solution. So this is when the lines are parallel, right? We have a graph, we have a line, and we have a line parallel to it. There's no intersection point, right? There's no intersection point. Now, some people might say, well, if you have a line like that and a line like that, they don't intersect, right? No, actually, because lines continue forever, right? They can continue forever in both directions, and then they'll eventually intersect. So that's why the lines have to be parallel in order to have no solution. Now, our third outcome is infinite solution. So let me write parallel lines here. Okay, infinite solutions. Now, what kind of line has infinite intersection points? The same lines, right? The same lines. So if you graph the same line, it'll intersect forever, right? So that is infinite solutions. Okay. So if you just graph the same line over and over again, then the intersection point will be infinite intersection points, right? Infinite intersection points. Okay. So that is infinite solutions. Okay. So infinite solutions is the same line. Okay. So does anybody want to take notes on these three outcomes? Okay, yes or no? Does anybody want to take notes on this? Oh, okay. Great, Shan and Carney. You guys were late. No worries. Okay, no worries. So how much did you miss, Carney and Great, Shan? How much did you miss? Because I can quickly go over the ones. About 10 minutes. Okay, that was 4 minutes ago. So about 4 minutes ago, we were going over systems, right? Systems. Okay, so today we're going to be doing systems of algebraic equations. So systems are just groups of algebraic equations like 3y minus 3 equals 9, 3x equals 9, and then x plus y equals 12, something like that. Okay, so this is a system. And then we are just going over the outcomes of the systems, okay? And Also, the solution to systems are the intersection of the two lines on a graph. Look, so this is in standard form. You can graph standard form. This is in slope-intercept. Okay, so these two algebraic equations can be both graphed. In the intersection of these two lines on the graph is the solution. So there are three outcomes of systems. The single solution is just the intersection point, and you write it in an ordered pair. Okay. The no solution is where the lines are parallel. Okay. Lines are parallel, they never intersect. Okay. Infinite solutions, you graph the same line. Okay. They intersect infinitely. So do you understand, Carney? You understand so far? Okay, that was a brief cap. Okay, good. So let's move on. Okay. So solving systems with graphing. As I said earlier, you have to graph those two lines and then find the intersection point. Okay. So graphing usually, why I included graphing was to help you understand and visualize that intersection point. Now, graphing isn't actually a very effective way. Let's say you have a graph. Okay, intersection point is actually a fraction. It's very hard to see a fraction intersection point. Let's say your intersection point is 0.001 and 8.5, okay? That's hard to see, right? You can only easily figure out intersection points like 5, 6, okay? Whole numbers. But all the practice problems that I included are whole number solutions. So after this, we're going to be introduced to some new methods called elimination and substitution. And those can be used to find the solution to systems even more faster, and then you can use that to find, like, maybe x equals a fraction. Then you can use substitution or elimination to find x, okay, easier, okay? So graphing is just for visualizing, okay? But now let's do some practice problems with graphing. So solving systems, right, with graphing, you have to graph the two lines first, right? So let's take an example. So y equals 5/3, okay, just 3x minus 4. And then y equals 2x plus 3, okay? So both lines are in slope-intercept form, which make them easier to graph, okay? So both lines are in slope-intercept form. Carney, Rayshen, Jocelyn, you guys all have been to my previous classes, so you guys should know how to graph. So for those who are new, I'll show it again. Slope-intercept form, okay, very easy. So in slope-intercept form, the coefficient of x is the slope, and then the number following it will be the y-intercept. So include the sign before. Okay, so the y-intercept would be -4. And then this y-intercept would be 3. Okay. So let's graph. Okay. So first we need to find the y-intercept. Okay. So 1, 2, 3, 4. -4, right? -4. Okay. And then this will be our slope, 3/1. Okay. 3/1. Okay. And then we have to use the slope to find all the points. Okay. So first, this is the change in y, right? Change in y, change in x. So 3 is the y. So positive 3, let's go 1, 2, 3 over here. And then go to the right by 1, okay? Over here, okay? This is our new point. And then we can repeat the whole thing, right? So this is our line, okay? Next line. We have a y-intercept of 3, 1, 2, 3. And then our slope is 2 over 1, okay? So let's go up by 2, 1, 2. Go to the right by 1. There we go. That's our line, okay? So very similar lines. And they do intersect at some point, okay? That will be our intersection point. And I'm not going to find out that because that might be a fraction. Okay, so that is a basic representation of using graphing to find the sums. Okay, so but in the problems that I give you, there are actually whole numbers, so you won't get any fractions, whole numbers. Okay, so let's start with this practice problem. Y equals negative 5. To use the x here. Y equals negative 5/3 x plus 1, okay? And then we have another equation, y equals negative 1/3 x minus 3. So that is our system. So please use graphing to try and solve this, okay? And your solution should be the intersection point. Write it in a ordered pair, okay? So you can write it like x equals question mark, y equals question mark, but since we're actually using a graph, okay, remember it's the intersection of the two lines, so it's a better representation of the problem if you write it in an ordered pair. So please try to solve this problem and put the answer in the chat when you're done. Okay. So I'll give you a few moments of time, okay, and solve this problem. Then we'll move on, okay? Then we'll move on. So, does anybody have any answers yet? Okay, almost. Very good. I'll give you some time. Okay? So I'll leave the slide up and then you guys can try to solve this one. Okay, I'll give you a few moments. Okay, so you can't see the equation. This is the system, okay? This is the system. So can you see it now? Can you see it now? Okay, so Ray-san, you don't need the graph paper. Just write a graph of your own. Okay, so I'll walk you through it, okay? On this tablet, I don't have graph paper either, so you just have to write a graph. Okay, very easy. Just y-axis, x-axis, and then you just have to mark them. Okay, just have to mark them. Okay, there we go. So our first equation, our y-intercept is 1. Okay, make that a point. Okay. And then we have negative 5/3 x. Okay, negative 5/3 x, that's our slope. Negative 5/3. Okay, so we have to go down by 5 and then to the right by 3. So let's go down 1, 2, 3, 4, 5. Okay, there we go. That's our point. If I'm not mistaken, yes, that is. So that should be our point. And then let's go up. So our reverse slope should be 5, negative 3. Let's go up by 5 and then to the left by 3. 1, 2, 3, 4, 5. 1, 2, 3. Okay. That's our other point. Okay. And then we can get a line. Okay. Mine is not so straight, but if you use a ruler, it should be a straight line. Okay. Second one. Okay. Y-intercept is negative 3. 1, 2, 3, right here. Okay. Our slope should be negative 1/3. Negative 1/3 or 1 over negative 3. Okay, so negative 1/3 go down by 1 and then go to the right by 3. Go down 1, 2, 3. And we get this point, right? We get this point. So that will be our intersection. So to make sure, let's do the other point. So let's go up by 1 and to the left by 3. Up by 1, left by 3. 1, 2, 3. Okay, right here. Okay, straight line. There we go. That is our intersection point. And okay, what is this? We have a 3, negative 4. 3, negative 4, right? So right here, that is 3, negative 4. So did anybody get that answer of 3, negative 4? Okay. So next problem. So in this problem, okay, number 2 is negative 2y minus 5x equals 2. Okay, and then negative 5x equals 2y minus 4. Okay, so this one, these equations are both not in slope-intercept form. In slope-intercept form, as you know already, is the easiest way to graph a line. So let's convert first. Okay. So this top line, let's convert that first. So move negative 5x to the other side, isolate y. Negative 2y equals 5x plus 2. So, and then we have to simplify even further to slope-intercept form. We want y by itself, not negative 2y. So divide by negative 2y. Okay. So y equals 5, negative 5 over 2x, and then minus 1. Okay. That should be right. Correct me if I'm wrong. So our next equation, let's simplify. Negative 2y equals 5x minus 4. Okay, we just interswitch these two. Okay, and then divide by negative 2, y equals negative 5 over 2x plus 2. Now, you get these two. Y equals negative 5 over 2x minus 1. Y equals negative 5 over 2x plus 2. Now, what is this? They're basically the same equation, right? Except different y-intercept. Now, last class, I talked about perpendicular and parallel lines. So, same slope, different y-intercept. What is that? That is a parallel line. And what are parallel lines? They have no solution. So, no solution. Okay, so because parallel not lines, they never intersect, right? They never intersect. So, recall from this slide, okay, parallel lines have no solution. So did everybody get that? Okay. Okay, very good. Very good. Jocelyn and Rachel both got no solution. Very good. So now let's do the substitution method. Okay, so let me show you how to do the substitution method. Okay, so y equals 2x minus 4, and 3x minus 2y equals 1. And substitution circles around the idea of equality. Okay, it circles around the idea of equality. So I'm not actually going to solve this question for you. I'm going to solve a example. Okay, so let's say x equals y plus 4, and then 4x minus y equals 15. Okay, so x equals y plus 4, right? So we have an x here, and that x is equal to this x, but that x is equal to y plus 4. So the substitution method is circles around equality, right? X equals y plus 4. So we can actually substitute y plus 4 as x. Okay, so let's substitute 4 times y plus 4 minus y equals 15. And what is this? It is an equation that only has one variable, right? And we already know how to solve equations with one variable. So let's solve this one. 4y plus 16 minus y equals 15. Okay, so let's simplify. So 4y minus y, 3y equals, move 16 to the other side, equals negative 1. So y equals negative 1 divided by 3. Okay, negative 1 divided by 3. So does everybody understand so far? Okay, does everybody understand? So yes or no, put it in the chat. Okay, great, Shan. Which part do you understand? Okay, kinda, that's good. How do you get rid of the x? Okay, so, Rayshan, let me explain again. So, our first equation is x equals y plus 4, right? X equals y plus 4. So we can substitute y plus 4, right? So let me explain in the basic concept. A equals 2b. And then we have 4a. Okay? If a equals 2b, then we can also substitute 2b in. So 4a equals 4 times 2b, right? Because a equals 2b. So we can substitute that in. So that's the basic idea of substitution. It circles around the idea of equality. Since x equals y plus 4, we can substitute y plus 4 in as x and get rid of the x. And then we only have an equation with one variable. Okay. Very good. And then after we get y, right? We get y. We have to plug in y, right? Now we know what y is, we can plug in y. Okay, let's plug in y. Let me erase this, these boxes. Okay, now we just need to plug in the y. So anywhere there's a y, we can plug it in for -1/3. So minus -1/3, that's just plus 1/3. And then x equals -1/3 plus 4. Okay. And usual, you just need to plug it in for one equation. So just plug it in for one equation, not two. It's easier that way. Okay, so equation number one looks easier. Okay, so x will just equal -1/3 plus 4. Okay, so common denominator -1/3 plus 12/3. What you get? X equals 11/3. Okay, so that is how you use the substitution method. Then ordered pair, 11/3. Y equals -1/3. Okay, there we go. Okay, Ray Shen, you still don't get it. Okay, so let me explain it again. So how about let's do some examples. Okay, so let's do some practice problems, and then you might understand. Okay, so let me walk you through this first practice problem. After that, I'm sure you guys can all do it yourself. So our system is y equals 2x minus 4. And our second equation is 3x minus 2y. Okay. So y equals 2x minus 4, right? Y equals 2x minus 4. And then we can substitute in 2x minus 4 for y, right? Y is equal to 2x minus 4. So we can substitute in 2x minus 4 for y. So our next step would be 3x minus 2y, which is 2 times 2x minus 4 equals 1. 3x minus 4x plus 8 equals 1. Okay? So that is our next step. And then we get 3x minus 4x negative x equals -7. And then x would equal 7. Okay, and after that, we have to substitute or plug in x at 7. So y equals 2, 7. 2 times 7 minus 4. Because x, we already know that x equals 7, right? And then we can plug in 7 as x. Okay, y equals 14 minus 4, which is 10. Okay, and then we get the ordered pair 7, 10. Okay, so that is how we solve. Okay, very good, Rayshun. No problem, Raishan. If you guys have any other problems, I can solve another example for you. Okay, very good, Jason, you understand too. So, next problem, this one, you have to convert first. Wait, no, you don't actually convert. That is graphing. Okay, so with this one, let's see if you can solve it by yourself. Okay, so remember, y equals 2/3 x minus 2. Okay, so you can substitute that in for y. Then you can have an equation with only x, right? And that's easier. And once you found out x, you can plug in the number for x and then find out y. Then you can put it in the ordered pair, okay? So I'll give you a few moments and then you guys can put your answer in the chat, okay? I'll be looking for answers in the chat. Okay, I'll leave this slide up. Okay. Jocelyn says all real numbers, which is infinite solutions. Infinite solutions, very good. So that's one answer. I don't actually know the answer yet, but okay, Rayshan also says infinite. Very good, very good. Jason. Okay. The answer is all integers or all real number. Okay, your second answer is correct because all integers, that's incorrect. Because all integers, what about all the decimal points between the integers, right? There's infinite points on a line because lines go on forever and those points can be decimals. So all integers is wrong. So you can say all numbers, all real numbers, or infinite numbers. Imaginary numbers, there's only a few of them, okay? Well, not a few. Imaginary numbers are like the square root of -1, which is I, okay? But that is, we're not working with that. Maybe algebra 2, then you'll work with those imaginary numbers. Like -4, the square root of -4 would equal to 2i or something like that, okay? Okay. So you guys have your answers already, infinite solutions, right? Okay, so let's solve. 2x minus, you can substitute, right? You can substitute 2x minus 3, 2/3 x minus 2. Here we go. And then that equals 6. Okay, very good. And then 2x minus 2x plus 6 equals 6. 2x cancels out. 6 equals 6. Now what is this? This is a true statement, right? And let me tell you, when you're working with substitution, a true statement means all infinite solutions, okay? Infinite solutions. Now, if you were to end up with a false statement, 5 equals 3, that's false. A false statement would mean no solution, okay? So in graphing, parallel means no solution. Same line equals infinite solutions. In substitution, hey, false statement is no solution, and then true statement is all real numbers. Okay. Now, in this problem, this is actually quite easy. You actually didn't even need to substitute it in. Take a look at this. Once you're familiar with it, you'll know. If this is standard form, right? If a standard form has the two numbers of the slope, there's a big chance that it'll be the same equation, okay? And also, the coefficient, -3 before y, so 6 divided by -3 is -2. So also check that. Because the slope of a standard form equation would be -a divided by b, right? And what is -2 divided by -3? 2/3, right? So that's the same slope. And then what is 6 minus the coefficient? 6 divided by the coefficient before y, right? That's 6 divided by -3, which is -2. And then you get the same exact equation, okay? So once you get more familiar, you can just see through that, okay? You can see through that. So now let's work with the elimination method. And the elimination method involves eliminating one variable, okay? In substitution, just substituted one variable for something else, okay? So maybe y equals x, x plus 4, okay? And then you can substitute in x plus 4 for y, okay? But that's not the case for elimination. In elimination, you subtract the equations. So let me tell you how you do that. So let's take our this first problem, okay? Y equals 2x minus 4. So y equals 2x minus 4. And then 3x minus 2y equals 1. 3x minus 2y equals 1. So 3x minus 2y equals 1. Okay, very good. So I copied the problem from our substitution problems. Okay, so this is equation 1, equation 2. So the idea of elimination is adding or subtracting the two equations. You can do 1 plus 2, okay? Or you can do 1 minus 2, or 2 minus 1, okay? You subtract or add those equations. Now you might be a bit confused now. So actually, that isn't a very good example, okay? Let me switch to another equation, okay? So 3x plus 4y equals 2, something like that, okay? So that is a better example to show you guys. When we subtract the equations, we subtract x and x, we subtract y and y, and we subtract, like the numerals, okay? And in this case, let's do 1 minus 2. So 3x, okay, so 1 minus 2, this is equation 1 minus equation 2. So 3x plus 4y equals 2 is our first equation. And that is supposed to be subtracted, and number 2 is going to be subtracted from number 1, okay? So what is 3x minus 3x? 0, okay? 4y minus negative 2y. That'd be 4y plus 2y. Okay, plus 6y, right? 4y plus 2y, okay. And then equals 2 minus 1, which would be 1. And then look at this. We have canceled out x by subtracting those two equations. We have canceled out x. So now we eliminated some, right? Y equals 1/6. Now we know what y is. We can plug in y, right? Plug in y. Okay. And you guys already know how to plug it in. So that will be my example for elimination method. Okay, so let's do some practice. Okay, let's do some practice. Okay. So I'll give you a few moments to try and solve this one. Okay, a few moments. Also, I'll give you a tip. When you see that the coefficient of the absolute value of the coefficient before the y is or before a variable is the same, it might be a good idea to subtract or add those two. In this case, 3y and negative 3y. If you add those, that equals 0, right? So it might be a good idea to try that. Okay, that's my hint. I'll give you a few moments to try and solve. Okay, does anybody have any answers already? Okay. Okay, Jason. I think this is referring to the last substitution one. Okay, yes. You can. And I did. There's Diana says she doesn't know. Okay, you can hang tight on that. And then I'll walk you through it. And then Rayshen says x equals 4. Very good. And then you just have to plug in x, right? Just plug in x to the equation and also get y. Okay? So what is y then? What is y? Okay, should be very easy. Okay. Jason says all real numbers. Oh, okay. And then Rayshen says y equals negative 3. Okay, y equals negative 3 and x equals 4. Okay, let's see if that's correct. Okay. So let's do this one. So remember, let's add equation 1, equation 2. Because we have negative 3y and 3y, we can just add them to get 0. So let's do equation 1 plus equation 2. So equation 1 plus equation 2, 2x plus x equals 3x plus 0, because 3y plus negative 3y, which is 3y minus 3y equals 0, equals 18. And then x equals 6. Okay, x equals 6. So Rayshen says, never mind, y equals 7. Okay, so let's see if that's true. So x equals 6, right? X equals 6. So we know that x equals 6. Let's erase this. And then we can plug that in, okay? So let's plug that in to this second equation. So x minus 3y equals 3. So let's plug this in. x equals 6. 6 minus 3y equals 3. Okay, let's move these terms. Okay, and we get 3 equals 3y. Y equals 1. Okay, 6, 1. Did everybody get that? Y equals 1. Okay. Very good for those who tried. Okay. Now the next one. This one is a bit trickier. Okay. And this one I'm actually going to walk you through on. Okay. Let's look at this one. This is a very interesting one because if you add, you can subtract all day long. You can add all day long. You're never going to eliminate one variable. Why? Let's try adding. 7x plus negative 3y equals 21. Okay, doesn't work. Let's try subtracting. Same result, doesn't work. Why? Because the two x's and the two y's don't have like negative 3 and 3, right? If you add negative 3 and 3, they're going to cancel out. But the coefficient, the absolute values of the coefficients before the variables, there's not one that is the same, okay? There's not one that is the same. So let's say you had 2x plus 6y. Then you can add the equations to eliminate y, right? But you can't do that right now because you only have 3y. And when we have that, you can say you have to enlarge the equation, okay? So this is when multipliers come into place. So multipliers, you have to multiply this top equation, equation 1, okay? Equation 1 by 2. Let's multiply equation 1 by 2, okay? So 4x plus 6y equals 30, okay? I multiplied every term by 2. Now you can do it, right? So this is our new equation, okay? 5x minus 6y equals 6. There we go. These are our equations, okay? Now you can add them, right? Let's add 1 plus 2, okay? 4x plus 5x, 9x. 6y minus 6y, 0, equals 36. X equals 4, right? X equals 4. So does everybody understand where I'm going from? Okay? Okay, very good. So now we just have to plug in x into one equation, right? So let's plug in it to the second equation. So let's erase all this. Make some room, and then 5x minus 6y. So 5 plug in x 4 minus 6y equals 6, and then we just switch negative 6y and 6. So 20 minus 6 equals 6y, and then 14 equals 6y. So y equals 14 over 6, which is also 7 over 3. Okay. So that is our last practice problem. So thank you everyone for listening to my class. Okay, thank you for listening, and be sure to subscribe to my YouTube channel and drop a like on this video. Okay.